Okay, hello everyone. Let us now try to answer example number 4. So we have a given equation here, and then we need to convert it to the standard form of an ellipse, and then determine the location of the foci and the vertices, and then graph the equation. Okay, so what do we need to do? First is, let's write our equation first. So we can start by subtracting 4 from both sides. Is equal to negative 4. Then we can group the x terms. 4x squared minus 8x plus y squared plus 4y is equal to negative 4. Okay, so we can factor out a 4 here. So we have x squared minus 2x plus y squared plus 4y is equal to negative 4. Okay, so we can complete the square here for this expression and also this expression. So 4 times x squared minus 2x, this is negative 2 divided by 2, that will be 1 and then squared, so plus 1. And then plus y squared plus 4y, so 4 divided by 2 squared, that will be 4. So we need to add. So first, we multiply this 1 times 4, and we add it to the right hand side, and also we added 4 here, so we also add to the right hand side. Okay, so what do we get? You'll get 4 times x squared minus 2x plus 1 plus y squared plus 4y plus 4 is equal to 4. Okay, so we can then express it as the square of a binomial. So 4 times x minus 1 squared, and then plus y plus 2 squared is equal to 4. And dividing both sides by 4, we will get x minus 1 squared plus y plus 2 squared all over 4 is equal to 1. So there you have it. So we can put over 1 here. So this is now our standard form of our ellipse. So as you can see here, the center of our ellipse is not at the origin. So it is at 1, negative 2, right? That is the center of our ellipse. So we need to determine the location of foci and the vertices. So in order to find the foci and the vertices, we need to find C and A first. So what do we have here from our equation? We can see that we have A is equal to A squared is equal to 4, right? So A is equal to 2, right? So our distance from the center of our ellipse to a vertex is 2, so positive negative 2. So and our b right here, so b squared is equal to 1, b is equal to positive negative 1. Okay, so in order to find the c, we can use a squared is equal to b squared plus c squared. So c squared is equal to a squared minus b squared. C squared is equal to 4 minus 1. So c squared is equal to 3. And then c is equal to positive negative square root of 3. Okay, so there you have it. So this is our c. We also have our a. Now, in order to find the location of the foci and the vertex, we need to take into account, of course, our center, because our center is not at the origin. Okay, so our center is at 1, negative 2, based on x minus 1 squared and y plus 2 squared. This means that from the origin, the center has been shifted 1 unit to the right and then 2 units downward. Okay, so 1, negative 2. So in order to find the equation, the location of the vertex, we need to use our a. So we also need to take into account the form of our ellipse. Okay, so if we take a look here, if we take a look at our equation, we can see that the denominator of the y plus 2 squared is greater than is greater than the denominator x minus 1 squared. Therefore, the shape of our ellipse is elongated vertically, right? Therefore, our major axis is along the line y is equal to, along the line x is equal to 1. Okay? Because from the center, let's just plot it first to avoid confusion. Okay? So let's plot it. Okay, we have it here. So our center is at 1, -2 here. Okay? And we know that our ellipse is elongated vertically. Therefore, our major axis is along y, x is equal to 1. So this is x is equal to 1. And this is our center. So in order to find the vertex, we need to add positive -2 to the y component. So -2, right? We need to add it to -2. Okay? So -2 plus 2, so that would be 0. That would be 0 right here. So this would be our vertex, and also -2 minus 2, that would be here at -4. Okay. So these are our vertices. Okay. As for C, so let's find out the coordinates first. So we have here 1 and 0. We also have here 1 and -4. So that is the location of our vertices. Those are the locations of our vertices. Now how about the foci? The foci is actually from here, the distance from the center to the focus, which is C. So we need to add square root of 3 to the y component of our vertex, our center. So we need to have, so for the location of the foci, you will get, so our x coordinate here is 1, and then -2 plus square root of 3, and then the other one will be 1, -2 minus square root of 3. Okay, so your foci will be somewhere along between here and the coordinates somewhere there, and the coordinates are -2 plus 1, -2 plus square root of 3, and 1, -2 minus square root of 3. Okay, so there you have it. We've answered letter B, right? And then also we need to graph the equation, so we can use the graphing utility for that. So if we do that, here we go. Here we get. So here it is. So 1, 0, and 1, -4 for our vertices, and 1, -0.268. So that is, if we evaluate this, -2 plus square root of 3, and also 1, -3.732 if we evaluate 1, -2 minus square root of 3. And as you can see here, our B, so our B is actually the distance from our center to the co-vertex right here, which is 1 and 1. So there you have it right there. So that's why their coordinates are 0, -2, and 2, -2. Okay, so thank you for watching this video, and I hope you learned something, especially about the shifting of the coordinates of an ellipse and how it can be used to solving problems. So instead of memorizing the formula for the ellipse at center HK. Okay, so thank you for watching. See you in the next videos.